Okay, so we talked about how we can find x with really easy equations, but in this video, I just wanted to show you that x is not that easy to find. Sometimes x can be sneaky, and we have to be sneaky with our methods as we're solving them. So let's just start with the first problem where we can see that x squared plus 2 is equal to 4. How do we figure out the value of x in this question? Well, the easiest way is to always remember that you're using the opposite of whatever is going on in the equation, or the opposite operation that's going on in the equation. So we have x squared plus 2 equals 4. Okay? Now, first I need to get rid of that plus 2, which means if I transfer it, or bring it in this side of the equation, the sign should change to -2. So x squared is equal to 4 minus 2. Okay. X squared is equal to 4 minus 2 is 2. Okay, how do we get rid of that 2? Well, as you can see, it's a power of x, which means whatever's happening, it should happen in the power of my 2, or it should happen with powers, not in the bottom. It's not like multiplying it, or it's not dividing x, it's on the top, it's a power of x. Let me make this kind of good. Okay, there we go. Whatever is happening, it should happen in the power. And because I want x to the power of 1, I should divide the power by 2, or multiply it by 1 over 2. If I multiply it by 1 over 2, it's the same as dividing it by 2. Which means if I do this to the power of x, I have to do it to the power of 2 as well. And what do you think the power of 2 is when there's nothing? When there's nothing, we know that the power is 1, because 1 is always sneaky and invisible. So we should always remember that there's a 1, and we're just going to multiply that by 1 over 2. Excuse me. So these two cancel out, and x is equal to 2 to the power of 1 over 2. What does that power mean? It turns out that's just our square root. That's a square root with a degree of 2, but because the degree is 2, we're not gonna write it. And can we have a square root with a degree of 1? No, that's impossible, because if it's a 1, we're not even gonna have a square root anymore, or we're not gonna have a root. That's just gonna be a power, and all we need to do is, in that case, to raise 2 to that power, and then we're gonna get our answer. But in this case, it's just x is equal to square root of 2. So let's say what happens when we have something like this. It's a square root 4 plus x equals to -5. As you can see, the 4 is inside with the x. In this case, all we need to do is to first get rid of that square root, or get rid of anything that's making the x be with 4. Okay, because we can rewrite this as 1 over 2, because we know the degree is 2, minus 5. Okay, how do we get rid of that? We already told you guys about the fact that this is a power, and because it's a power, we should multiply it or divide it by something to get it to 1. And it's only gonna happen to the powers, not to the numbers. Meaning that I'm not gonna, if I multiply this by 2, I'm not gonna multiply the number by 2. I have to multiply the power, which is 1, by 2. If we multiply that and we multiply this, these two cancel out. 4 plus x is equal to -5 to the second power. And -5 to the second power means -5 times -5. And -5 times -5 is going to give us 25, positive 25. And because I want x by itself, I have to move this from this side to this side, which means I have to change the sign from +4 to -4. So x is equal to 25 minus 4, and x is equal to 21. There we go. Okay, how do we do this problem? As you can see, this time it's different because x is in the power. If x is in the power, always remember to look at the right side of the equation because there's something that's going to help you out. So if I look at 16, 16 looks like something that's divisible by 2. If I divide it by 2, I get 8. If I divide it by 2 one more time, I get 4. If I divide that by 2 one more time, I get 2. As you can see, I get a 2. And my goal is to make these two numbers equal to each other. Since this is 2 and that is 2, I can basically write this as 2x plus 1, 2 as my base, but my power should be something else because I should get to 16. I'm not 2 anymore. And did you guys see how I stopped when I got to 2? Because I can again divide this by 2 and I should get 1. But I am not going to be doing that because I don't need 1. I need 2. I need 2 because I want the bases to be equal to each other. When the bases are equal to each other, that's when the powers are equal to each other. Okay? So let's see. If I have this, okay? Now 2. Now all I need to do is just go back and get to 16. How do I go from 2 to 16? Well, I need to multiply it. I need to multiply 2 multiple times by itself to get to 16. Okay, if I multiply 2 one time with 2, I get 4. If I do it 2 times, sorry. If we do 2 times 2, meaning if I multiply it by 2, I get a 4, and then 4 times 2 is 8, and 8 times 2 is 16, which means I'm multiplying 2 4 times by itself. How did I do it? I did 2 times 2, that's gonna give me 4. 4 times 2 is gonna give me 8. 8 times 2 is gonna give me 16. Okay, now that the bases are equal to each other, we already know that the powers should be equal to each other, meaning that x plus 1 equals 4 should be equal. They should be equal to each other. Okay. Now, because I want to have x by itself, I need to move the plus 1 to the other side, meaning I should make it negative. 4 minus 1, x is equal to 3. And if we put it back here, we get 3 plus 1, which is 4, equals to 2 to the 4 power. And as you can see, these two are equal to each other, but if you want to simplify it, it's going to become 16 is equal to 16, and that is correct. And this is how we can do all these kind of complicated looking questions. But always remember that it's not always going to be this easy, but if I use something that's kind of difficult, or if it's something that you should know, I will be making videos about it. But this is it for today. Thank you.